Okay, in this video, we'll be discussing about how we can implement linear regression in Splunk MLTK. Okay, so in my previous video, we have seen how we can install Splunk MLTK and its related packages, right? And also, if you remember, when I was discussing about the machine learning core algorithm, I was also introduced the core data set we will be using for our linear regression modeling. Okay, that's the graduate admission data set where we have for various students we have their GRE score, TOEFL score, university rating, statement of purpose rating, okay, reference rating, CGPA, whether they have done research or not. Based on all these fields, we will try to predict the chances of admit. Okay, so now to implement linear regression, so we will be implementing linear regression for this one and see how best the model is fitting the particular data. Okay, so to implement linear regression, what you have to do, you have to go to Splunk machine learning toolkit. Okay, as I stated before, the landing page of the machine learning toolkit app is the showcase dashboard, right? Where it has basically a lot of examples based on whatever the different machine learning algorithms Splunk supports. Okay, now to implement the machine learning on your own data set, what you need to do is you need to come to experiments tab. Okay, so now if you do not have any other models or if it is the first time you are coming to this particular dashboard, this will be the default view. Okay, but if you have already experimented on different models, the view will be slightly different, which we'll see later. Okay, so now as in linear regression, we are trying to do a prediction on the numeric field, right? So we will go over here. Okay, the predict numeric field, we'll clicking over here. Now it is asking me for an experiment title and a description, so I'll say graduate admission prediction. Let's give the experiment title like this one, prediction. Okay, now you can give some description as well, meaningful description. So I'll click on create. Okay, so now this particular view comes up over here. Now if you see here, we have two tabs, experiment settings and experiment history. Initially the experiment history will be blank, there is nothing over here. Okay, now based on the experiment settings, experiment history will be updated accordingly, which we'll see it later. Okay, now the first thing is it is asking me for a search, right? So now let me show you the data. So this particular data I already indexed in my main index. Okay, so I'll just write the query, index equals to main, and just tabling it all my different features and chances of admin. Okay, so this is my data set. So this data set I will be using it for my training purpose, not the full data set, not all the 500 records. Maybe some of the data I will be using it for training purpose, and the rest of the data I will be using it for the prediction purpose, just to see how my model is working. Okay, so I'll give this query over here, and then I'll click on search. Okay, so by default it is showing me this is the my data, initial data preview, right? Now let's go to the next one. So here if you see, there are a lot of pre-processing steps over here, right? So now in machine learning, when you train a particular model, right, you there may be some need to pre-process their data so that you will reduce a lot of noise from the data. Now there are a lot of pre-processing algorithm present over there, so when we will discuss those algorithms, we'll come back to this page again and work on it. Okay, so for now I'll not be doing any kind of pre-processing because this data is clean enough data. Okay, so Now the algorithm, I will be choosing linear regression. Now there are a lot of regression algorithm. So currently we studied only about linear regression, and we'll be implementing linear regression only in this video. So I'll be choosing the linear regression over here. Okay. So now fields to predict. That means which field you want to predict. So as I will be predicting my chances of admit, I will be choosing that. And then field use for predicting, that means here basically you are choosing your features, right? So I will be choosing all my columns. So here if you see, the concept of simple linear regression and multiple linear regression comes up, right? If I choose a single feature, it will become a simple linear regression. If I choose multiple feature, it will become a multiple linear regression. So for now I will be choosing for all. Okay. Now here if you see the split for training, right? So here basically it is what is happening is you are splitting the whole data set between a training and test data set. Here currently it is 50% 50%. That means the first 50% data will be used for training and the rest 50% data will be used for testing purpose. I'll slide this one, you can slide this one. I'll keep 70 and 30. Okay. Now fit intercept. Okay, that means if you remember from my machine learning video, not only we have the slope value for each and every feature, we also have a intercept of y-axis intercept value, right? So by this option you are basically choosing whether your model should include an implicit intercept terms or not. Okay. Now notes, you can give some meaningful notes. Maybe the notes could be like what are the fields you are using for prediction purpose. So and some meaningful note which will be useful in later when we'll see the history of the model. Okay. So I'll say using all the features, using all the features. Okay. Now after all is done, you need to click on fit model. So it's basically behind the scene what it do, it runs a Splunk custom command which basically implemented I think in scikit-learn. So using that particular command, it is trying to come up with the equation of that line, right, which we discussed before. And if you remember from my multiple linear regression video, we come up with a linear algebra solution over there, right? With matrix inversion and matrix transpose, right? So behind the scene, it is doing the same thing over there. Okay. So now if you see, the result came up, right? For after clicking on the fit model. Now if you see, apart from our own data, it's actually added two new columns over here. One is the predicted chances of admin and the residual column, right? Now predicted chance of admin is actually the actual prediction happened on the data, right? So if you see for the first row, the actual chance of admit is 0.73, that means 73%. Now the predicted was 0.70, that means 70%. So the residual column is the difference between the actual chance of admin and the predicted chance of admit. Okay. So this is how after fitting the model, it came up with this kind of visualization. It also shows up there are other 5 to 6 charts over here. Okay, now let us discuss one by one this one. Now the first chart show me the actual versus predicted line chart. That means if you see the chance of admit, the blue color graph is the actual one, and the predicted chance of admin, the yellow color one, is the prediction one, right? And if you see, by seeing this one, we can at least see this particular model is okay fit to this particular data. Somewhere it is lagging over here if you see it, right? But somehow it's actually fitting good over there. Now the residual chart, whatever you are seeing it over here, the line chart, it is showing up over here. Okay. So now the more this chart, particular chart is close to zero, that means the model is fitting really good. But over here if you see the latter part of this one, the residuals are more, right, because it is more sparse, more distance from the zeroth line. And the same thing is reflecting over here as well. The model has some kind of lagging over here, right? So So this kind of analysis you can do it from there, how the model is fitting your data. And this particular graph is showing me the scatter plot of the actual and the predicted one. And here basically you can see the how the line is fitting your data over here through this chart. Okay, now it also provides a residual histogram where let us understand this one as well. So where we have the zeroth line over here, if you see, it basically shows up for each and every residual value how many counts are there, if you see. So if you just think about it, if for all my data points this residual is 0, that's the ideal scenario, right? That means I am predicting really well, right? So from this histogram, if you see, that means if you see the residual error equals to 0, the sample count is 24 over here, right? If the more and more samples are very close to this 0, that means my model is doing good. It's actually good fit model. And if it is more sparsed, if that means if we have more number of big lines over here, that means the somehow the model is not a good fit for that particular data. So this kind of interpretation you can do it from this particular diagram. Okay, so now there are another two things over here. It's called R squared statistic and root mean square error. Okay, so these two are actually a measure about how accurate the model is. Okay, so I'll be discussing this measurement in very detail in separate video. There we'll be discussing about R square statistic, root mean square, and also some other way to determine how the accurate the model is, just like bias, variance. There are a lot of other measurement as well, we'll discuss in detail over there. Okay, but for now just try to remember, like, this is the fit measurement of fit. Like maybe R square statistic, we can think of it, if it is more close to 1, it's a good fit, something like this. Okay. So we will see like how to best judge a model based on that. Okay, but still, like even for R square statistic, it's all depend on the context, the field you are solving, you are implementing linear regression as well. We'll discuss those stuff as well in future. Okay, and now if you see the last graph, it is showing me the model parameters. If you remember the big equation, we have written it over there, right? So let me open the bamboo paper here. If you remember, when we talked about multiple linear regression, we started our discussion with a big equation, right? So let me go back over there. Yes, so this one, right? So where beta 1, beta 2 to beta p is our slope value, coefficient of each and every feature, and beta 0 is my intercept, right? And what we are doing basically, at the end of the day, we came up with a big equation to determine this whole beta vector, right? So this is the same stuff over here it is representing. So it is basically giving me, like, for each and every feature, what is the coefficient value. Okay, so and the intercept value as well. If you see, this is my beta 0, and my beta 1 to beta p is this guys, other guys. Now if you see it closely, there are some of the coefficient which have very greater value, some of the coefficient which have very less value over here, right? The way to interpret the coefficient is like how much it is influencing the end result. So to understand that, let us see this one. Let's say I have a variable called x, and I am writing something like 0.9y. Now what do I mean by this particular equation? 0.9 into y, right? So that means if I give y equals to 1, that means my x will become zero point 0.9, right? So what do you mean by that? That means 1 unit change in y it's basically zero point 0.9 unit we are changing in x, right? So this kind of interpretation you can do it. So that means how y is influencing x, right? So this is how we are interpreting this kind of coefficients as well in linear regression. So that means we will know from the coefficient itself which particular feature is mostly influencing that one. And now if you see it over here, I think CGP is the most influencing factor to determine whether my chances of admit is higher or not, right? uh, Considering we are implementing a linear regression, there could be a better fit of this particular data which we need to experiment and see. But for the current linear regression implementation, we can conclude this kind of stuff over here, right? Correct. So this is how the model uh, parameters summary uh, visualization, table visualization is telling me those details, right? So now if you see, we actually fit our model, right? So we still not created our model until and unless we are saving it. That's why it is showing me as a draft status of your model, right? And you can now go to experiment history to see what you have done till now. So it will be maintaining a history over there. So now I can see using this all these features, my R square statistic is somewhere around 78%, and these are my coefficient, and I am coming up with a conclusion that maybe CGPA is the most influential factor over here. Okay, so let us do another experiment. Okay, so in here I'll keep my CGPA over here just to see whether it's actually true or not. So, okay, so now what I'll do here is I'll keep CGPA, I'll give just the top 5 one, I'll keep the LOR. Okay, I'll keep the research one, and I'll keep the GRE score. Okay, so I'll click over here again. I'll keep the GRE score. I'll remove the TOEFL score. I'll remove the university rating. I'll remove the SOP, CGPA, research, and LOR. I'll keep. So now I am trying to do this experiment with 4 features, which I am thinking maybe most influential one. So maybe the other feature may not have much impact on this particular prediction. Okay. So now using only, I'll keep a note, using only 4 features. So this is how this particular note is coming into handy over here, right? So it is, when I will see the history, I will come to know what I have done over there. Okay, so I'll click on fit model again. Let's see how it's working now. So similar stuff is happening over there. It's running that custom commands. In later videos, we will discuss in detail of those custom command as well. Okay. Okay. So now if you see it again predicted that one. Now if you see from the actual versus line chart, it's more or less keeping same, even though I removed 3 features, right? Even this one as well, more or less okay. Now if you see, my R square statistics has improved a lot with 82%, right? So by this one, at least I am confident that really those 3 features are not impacting much of it. And if you see from this one residual histogram, the more and more features are very close to 0, right? With residual error, more residual errors are very very close to 0, right? So by this kind of analysis, we can say this particular model is better than compared to my previous model, right? So now what I'll do is I will save this particular model. Okay, so I'll give the experiment title as graduate data predictor. Okay, I'll click on save. So now a model will be created. Okay, so now if I just, you have two options over here after you save the model. Either you can go to the listing page or you continue editing. Okay, let us continue editing to see how experiment history is looking now. Now experiment history has two rows over there. Okay, the first row is the current experiment with my four features, right, with r square value of 82%. The second row is telling me my older one, right? So at any point of time you can load this corresponding settings and experiment with it. Okay, it will also show you the data corresponding to each and experiment. Okay, so now let's go back to our experiment tab and see what is happening over there. Okay, now if you see my experiment tab, it's not showing me those big blocks, right? It is showing me this kind of view where I have a predict numeric fields, a single experiment I have done. I have given the experiment name like this one, right? The algorithm I have chosen linear regression. There are a lot of actions you can do on this particular model. So before publishing, let us talk about that one. Okay, you can create an alert from this model just to see. So suppose the model is predicting data, right? So you can choose an alert, create an alert something like when my predicted chance of admin is greater than 90%, that means 0.9. Okay, 0.99 maybe, that means the model is really working good over there, right? So this kind of alert you can do. Okay, next you can edit the title and description. It's simple enough. Now you can schedule a training. This is an interesting feature where whatever we have done till now, we have done a manual training over there, right? Now in the schedule training feature, that you can create a scheduler which will run a training based on the data. Now if you see there is a time range over there, so you can choose the time range of the data you want to use for training purpose. Okay, that's a really interesting feature you have. So that means the more and more data coming to your system, you can use those particular data, right, to training purpose as well automatically using this schedule training. Okay, and similarly for other scheduling stuff, the schedule priority and schedule window, you can set it up as well. Even you can trigger an action as well when the schedule is happening. Either you can run a log, you can send a log file, output to a lookup, everything, just the normal scheduling purpose. Okay, that is also you can do over here. So this is a very versatile feature as well with the model you can do. And now you can delete it as well, that's fine. So now we will publish this model. Okay, we'll say chances of admit model. Okay, this is the model name and the destination app you will be choosing over here. So the model will be saved over there. Okay, I will be choosing my search and reporting app. I'll click on submit. Okay, so the model is created now. So how the model is created in the background, it's basically a lookup file. So let us see that. Okay, so from the Splunk home, etc apps, search, okay, lookups. Okay, so currently if you see it over here, it's the by default the model is saved as a user context, so it is, that's why it is not coming up under search. So further what I need to do, I need to go to etc, then I need to go to users. Currently I am the admin user. I'll go to admin and I'll go to the search app, and here in the lookup folder, this is how the model is getting stored over there. Okay, so I think this lookup is in read-only format. So if I just open in notepad, so this is how it looks like. So this is basically saving a lot of the information, the metadata related information about the model over here. Okay, what are the feature variables, what are the columns I have in my data. Okay, all of these things. Apart from that, there are a lot of other features which we do not have any control about. It is saving over there. Okay, so now we created our own model, right? Now we need to apply this, right? How we are going to apply this? There is a command called apply in Splunk MLTK. Okay, so by using that command, you can apply that particular model on any data set. Okay, on, or specifically we'll be doing in related data set itself. Otherwise, if you apply that model on any irrelevant data set, it will anyhow not going to give you a proper result. So this is how you will be applying the model. So I'll have my, this is my data set, base data set, right? I'll just choose, say, last 100 records. Okay, let's last 200 records. Okay, now I'll be using the apply command. Don't worry about it, I'll be discussing this Splunk MLTK commands in detail in my next video. So here we'll just see how we are just applying the model. So now I'll see my apply command, then my model name, right? So we have given our model name as chances of admit model. I'll just copy it. Okay, and I will just run it. So what it should do, basically it will apply this particular model, or that whatever. Okay, so it is permission denied, it is saying up. So for that, what I need to do is settings, lookups. Okay, lookup table files. I'll choose this one, search and reporting. Okay, this is my chances of admin model. Currently it is in private mode, that's why I'm not able to apply it on from the search app. So I'll choose this app only, read write. Currently I'll click on save. Okay, internal error, data could not be retained onto. Okay, so let me see what's going on over there. Okay, so I think there was some technical glitch, so I just did the permission again, and I this time I chosen all apps. I think it works now. So now let us see whether our search is working or not. Okay, so I have taken the last 200 records, and I'm just clicking on apply the machine learning one, machine learning model. So it is, if you see that it is applying that model on this particular 200 records, 200 events over there, and it has created a new column called predicted chances of admit. Okay, so this is how we are applying that model. Even you can create your own alert using this particular command as well, so that whenever you want something like chances of admit is more than 90%, 80%, or any other alerting you want, you can use this particular command to achieve that same thing over there. Okay, so this is how you can experiment with machine learning, specifically the linear regression in Splunk MLTK. And we saw a lot, there are a lot of experiments we have done it regarding this one, right? So this is how you experiment with your data as well, and see how it's best fit your data, and you can achieve a lot of other stuff like automatically training, creating alerts from these things as well. Okay, in next video we'll talk more details. We'll basically deep dive into what basically internally happening over here. We will talk about different Splunk commands internally running, the custom commands internally running, and whatever we have done, this experiment we have done from the UI, the same thing can be achieved from the search command as well, from Splunk SPL as well. Okay, see you in next video.